Welcome to a little bit of graphing rational functions, everyone. So in this video today, we are going to do a little bit of work together. This is attached to your Unit 5 workbook for those of you who are my students currently. So we've already talked a little bit about how to find the vertical asymptotes and the holes for a rational function. So just remember that your vertical asymptotes are going to be those situations where you have a number that creates division by zero. Right? So we don't want to be dividing by zero because that creates either the situation where you might have a hole or a vertical asymptote. And depending on what the factors in the numerator are, you might have a hole. And then, of course, if you have leftover factors in the denominator, you might have a vertical asymptote. Okay? So we're going to do a couple questions here, and we're going to look at all the different pieces that I'd like you guys to be able to find when you are coming across graphing these rational functions. So if you don't already, for a particular problem, have these things listed, like what are their holes in the graph, if any, what are the vertical asymptotes, you can abbreviate that VA and HA for horizontal asymptote if you would like. And then knowing the X and the Y intercept are always going to be important pieces as you're trying to graph your rational function. So let's start with where we left off, right? So we kind of left off with this discussion of finding discontinuities when you're dividing by zero. And we know that if you have in the denominator a factor that includes a value or a number that is going to create division by zero, that is potentially a vertical asymptote or a hole. Okay, and then it's going to be a hole if you have a factor in the numerator, like we see here, that is exactly the same as the factor in the denominator. So as we go through kind of thinking about and analyzing this particular rational function, let's start with just noticing the x plus 3 and the x plus 3. And most of the work you guys are going to be doing, you're going to have to be doing the factoring yourself. So this one's kind of nice. It's already factored for us, so that's a bonus. Your x plus 3 and x plus 3 can cancel, which means you have a hole at -3. Okay, whatever makes that factor equal 0. The leftover factor in the denominator is your x minus 3 here, so it looks like we're going to have a vertical asymptote, and we're going to write that in terms of its equation at x is equal to 3. So we have a hole at -3 and a vertical asymptote at 3. Now, horizontal asymptotes. Okay, this gets into some of the learning that we were just kind of bridging into as I talked to you last time, and we hadn't quite gotten to yet. And I think this is a nice little summary that you see here of analyzing your horizontal asymptote. You need to remember that when we think of the degree of the numerator m and the degree of the denominator n, that is when it's completely multiplied out in standard form. And so we're really looking at, x to the m dot dot dot, right? It's some kind of standard form in the top of your polynomial function, and then x to the n dot dot dot, because that could be any polynomial function in the numerator and the denominator. But you're really analyzing this value of the degree, and I like how this particular author, I kind of just grabbed this off the internet, utilizes this idea of if m is less than n, right, then y equals 0 is your horizontal asymptote. If m is greater than n, there's no horizontal asymptote. There might be, in this case, a possible slant asymptote. So we'll talk about that. And then if m is equal to n, then you're dividing the leading coefficients. And so that means the leading values, the numbers that are in front of, in this case, it's just 1 divided by 1. But you might have different numbers as your leading coefficients that create different asymptotes. Okay? So let's finish this question number 7 here and look at our horizontal asymptote. And we need to remember that if this wasn't already factored here on number 7, that you would have actually an x squared, and it looks like it would be a plus 2x and a minus 3, right? If that was all multiplied out together. And then you have an x squared and a minus 9 in the denominator. So the reason I like to kind of look at these first is I think it helps with a couple of things. And in this next one, we might tackle those two things first before we start factoring. It helps us to analyze our horizontal asymptote. So we see the degree of the top is the same as the degree of the bottom, and the leading coefficient here is 1, and the leading coefficient here is 1, which means my horizontal asymptote is located at y is equal to 1 divided by 1, or of course 1. Okay. Another nice thing about having this all still in standard form in the numerator and the denominator for the polynomial is analyzing the y-intercept. And the reason I like this is because when we are analyzing the y-intercept, what we know we are doing is plugging a 0 in everywhere we see an x. Okay, so 2 times 0 minus 3. And right here on the bottom, we have 0 squared minus 9. And we know that 0 times everything is just going to be 0. So we end up, and it's very easy to see almost without even plugging in the zeros what your y-intercept is going to be. So in this case, it's going to be a positive 3/9 or 1/3. So we have a y-intercept of 1/3. Okay. And then, of course, in order to find the x-intercept, which is the last piece that we have to work through here, we are going to plug a 0 in for y. So plugging a 0 in for y means that we actually, because I'm going to multiply both sides by this denominator of x squared minus 9, I'm just going to multiply. I'm going to show you it this time, right? These cancel. 0 times x squared minus 9 is just going to be 0. So really, when you're finding your x-intercepts, you are working with the factors that are in the numerator, right? So we have x minus 1 and x plus 3, and you'd think, oh, well, maybe, negative 3 could be an x-intercept, but don't forget that we already have x is equal to negative 3 as a whole for our function. So that's going to kind of be what happens at x equals negative 3. And then let's take a look at the other one. So if we set this x minus 1 equal to 0, then we get a positive 1 for our x-intercept. Okay? So there's a lot that we have talked about. We've talked about finding the holes with those common factors that are in the numerator and the denominator. We've talked about vertical asymptotes, horizontal asymptotes. Finding your x-intercept, we set y equal to 0. Finding the y-intercept, we set x equal to 0. And now it's time to put all of this together and graph. Okay, so let's start with our vertical and horizontal asymptotes. So I'm just going to make those this color, right? So there's our horizontal asymptote at y is equal to 1, our vertical asymptote at 1, 2, 3, just like that. We have an x-intercept at 1, so right there. We have a y-intercept at 1/3, just a little bit higher. And we know we are going to have, because the graph passes kind of along this path, just like that, and it's going to be passing along this path over here. We know we're going to have a hole at x is equal to -3. So 1, 2, here's -3. There's going to actually be a hole in my graph right there, and I'm going to indicate that with an open circle. Okay, so many of you are going to be wondering about how I know where to graph the remaining points that I see here. If you are doing this without a calculator, the best way to kind of figure out where those remaining points are going to be is to actually make a table and maybe try to plug in some additional points. So for this particular graph, if I didn't know it was already looking like this, I might plug in -1, maybe something a little farther out. I know that's going to be an asymptote, so I kind of know it's getting really close right here. I might plug in I already know what it is at 0, so, and at 1. So maybe I'm going to plug in a 2, maybe a 3, and an 8, just to, I don't need to plug in a 3 because that's going to be a vertical asymptote. But numbers that are going to allow you then to figure out by plugging them into your function what your corresponding points would be. So that is one way that you can double check your work. All right. Whew. That was just one problem, and we have a couple more to do. Okay, so what I'd like you to do is I actually want you to try this next one on your own. So this is in number 9, I believe is still on page 5 in your workbook. And so I want you to open page 5 in your workbook and try number 9, okay? Try number 9 on your own. See if you can use this information that you see here. Pause your feed, your screen, try it, and then come back, okay? And when you come back, all the correct answers will be magically here in front of you. All right, go ahead and try it. Poof! And just like that, you have the answers in front of you. Now you may need to pause the video again to kind of check some of my work against some of your work, and that is totally fine if you need to do that. Let me just point out a couple of things as you go through this that you can kind of take a look at. So the analysis of starting with the holes in the graph, vertical asymptotes, horizontal asymptotes, I always start first with the horizontal asymptote and the analysis of the degree of my function. And I also use this straight away to find my y-intercept. So you can see that calculation over here to the right. And then we go through this process of factoring. And as soon as we factor, we can see that there is a hole at 3, your vertical asymptote at -3, and then calculating your x-intercept. Again, I set y equal to 0 and solve for that here to the right. And then you go about your graphing. Now you'll see a little table that I made over here, and that is just an example of, I went ahead and I plugged in -5 into my rational function and got a value of y that corresponded to it. And you can see it right here, that value of y that corresponded. So I was able to, and then plugged in a -1. So I was able to get a couple more points on my graph that helped me to see my graph just a little bit better. All right, so I hope that went okay for you guys. I do want to make sure that this video doesn't get too long. And one of the things I do want to make sure that you see before we go on to our next piece of work is I want you to see just a couple of things here. Okay. So one of the things I'd like you to see is an example actually of a horizontal asymptote that is y equals 0. And what you can see here is that the degree of the top is a 1, first degree, like linear polynomial, and the degree of the bottom is a second degree polynomial. So because the m, right, our rule is less than the n, then we know right away that our horizontal asymptote is at y equals 0. Now, one of the things that can happen is this really is behavior, right? as x goes to infinity and as x goes to negative infinity. Because what we're going to see with this particular graph is that you actually do have a value along the x-intercept that actually works, all right? So your horizontal asymptote, it doesn't mean there won't be a point locally that might exist on that line y equals 0, but the rest of the graph for y equals 0 is going to be bound by your horizontal asymptote as x goes to infinity and negative infinity. Okay, so the two things I said I like to do before I factor are my horizontal asymptote and my y-intercept. Okay, so that's going to be just plugging a 0 in for x. And so kind of what I imagine is I imagine these all being 0, the x that you see here, here, and here. And I can just do some mental math and grab those last two numbers and know my y-intercept is going to be a negative 1/2. Oops, no, I don't want to open up my Outlook. There we go. Okay, so that's my y-intercept. And then after I do those two pieces, then I like to go to the factoring. Okay, so here we go. X plus 1 is a factor in the top. In the denominator, it looks like I have what? An x plus 2 and an x minus 1, right? Just like that. Get that on there. And so because I have no factors that are the same in the top and the bottom, I would say I have no holes in the graph. I could just say none or not applicable, whatever you decide to put right there. None is fine. My vertical asymptotes, I'm going to have 2 on this one, right? So remember, to find those vertical asymptotes, we are looking for division by 0. So what creates division by 0? All right, we can kind of look at these and figure that out. It looks like a negative 2, right? X equals negative 2 is going to be an asymptote, and x equals 1 is going to be an asymptote. And then my x-intercept is going to be found as I set my y equal to 0. And as you can imagine, the denominator is going to be multiplied on both sides. I'm not even going to show that this time. And we get x is equal to a negative 1. Okay, so negative 1, 0 is my x-intercept. My y-intercept is 0, negative 1/2. Okay, so I'm going to go ahead and graph this. I'm going to take a little minute to graph this. This might be a situation where you would want to make a table, because sometimes it's hard to tell what's happening with the graph if you don't plot some additional points, okay? Or if you're able to use your graphing calculator, that's also fine as well. So I'm going to go ahead and try, let's see, where are my asymptotes? Vertical, negative 2. I'm going to go ahead and do a negative 3. And I think also not 0, because we know what's happening there. Maybe... maybe a 2, maybe a 3, I guess. 2 and a 3. Okay, so I'll be back in just a minute. I'll do those calculations and we'll take a look at what this graph looks like. Okay, and if you guys want to try and graph it while I'm gone, which will in your world only be a split second, you can certainly try that. All right, 1 sec. We're back. I wasn't gone very long, I know. Okay, so in addition to graphing number 10, I went ahead and did number 11. So if you don't want to see it, don't look real fast, turn it back off and try number 11 on your own. Our video right now is getting a little bit long, so I want to try and wrap things up so this isn't too long for you guys. I do want to point out a couple of different things as we finish off this video and kind of go into what we're going to be working on this upcoming week, which is a lot of graphing and analyzing our rational functions. And also we're going to be working on some operations on rational functions soon as well. Okay. One of the things I did want to share with you is to find the actual location of our hole. We know that we have a hole at 2. Okay, and remember the reason for that is my factor of x minus 2 and x minus 2 are the same in the numerator and the denominator. If you want to figure out the y value of your whole, not just the x value of your whole, what you can do is you can take the part of your equation that is left and actually plug in that value of 2 into your equation. So if I plug in 2 for x, even though we know there's going to be a hole there, I realize that, right? 2 plus 1, y is equal to 3. So if x was 2, y would be equal to 3, which means the hole is actually located at the point 2, 3. That's its coordinate point. So being able to actually put that value of x back in to solve for the y coordinate of your hole will help you with graphing as well. And then I think what we'll do, this is a really, really nice example from page 8 of working through a slant asymptote. And we know it's going to be a slant asymptote, and I'm just going to talk to you about that part of this equation right now, just to kind of give you a preview of where we're heading this way. We know that it's a possible slant asymptote because the m value, the degree of m, is exactly 1 more, right, than the degree of the denominator. So if the degree of the numerator is equal to n plus 1, right, the degree of the denominator plus 1, then there's a possible slant asymptote. All right. We know that the vertical asymptotes we can find, we know that the horizontal asymptote in this case is there is none, right? We might look for holes. Okay, we want to know, okay, if there is a slant, we want to know how to find that. And I'm going to show you right now. And then we'd want to find the x-intercept, right? And we'd want to find the y-intercept. We'd want to find all of these things, okay? And we know how to do all of it except for finding the slant asymptote. So this is how you find the slant asymptote. It requires that you do a little long division, okay? And that long division for this particular problem is going to look like this. You need to keep your placeholders, right? And we're going to divide x cubed minus 0x squared. You notice there is not an x squared term, minus x plus 0. And we're going to divide that by negative 4x squared plus 12x plus 0. Okay? So I'm going to go ahead and remember in your long division, right? Remember this video is intended to be sort of interactive. In your long division, all right, you want to be thinking, what do I multiply a negative 4x squared by to make it an x cubed? So you're going to have to get creative with this one here, and that's going to be a negative 1/4 x. So I'm going to zip through this real quick and then we'll call it a day. Okay, so we're going to go ahead and multiply, get x cubed. When we multiply by negative 4x squared, we're going to multiply by plus 12x, get a negative 3x squared. And remember, I'm subtracting. The x cubed go away. I'm subtracting a negative 3x squared, so I get a positive 3x squared. I'll bring down my minus x, and then you ask yourself again, what would I multiply negative 4x squared by to make it a positive 3x squared? Okay, you have to get a little creative with this. Think about that. What might that be? It's going to be a negative 3/4, because if I multiply a negative times a negative, I get my positive 3x squared. Negative 3/4 times my plus 12x is going to be minus 9x. And what ends up happening here as you subtract is the remainder is really not a part of the equation of your slant asymptote. So it's okay to have a remainder. In this case, our remainder is 8x, and it really doesn't make a difference in your slant asymptote. What you want to get is this linear equation right here. So the equation of your slant asymptote turns out to be y is equal to negative 1/4 x minus 3/4. I'm going to do this to you one more time. Hit a pause if you don't want everything to, show up right away. If you want to try the rest of this on your own, hit pause for a second, give it a shot, and I'll be right back to share the answer with you. There you go, guys. There is the graph of number 7 from page 8. So a lot of interesting things happening with this particular problem. You've got a hole because of this factor here, x times x. Those are the two that are the same. And that sometimes is hard to see if you're not looking for it. But anyway, try it. Kind of take a look at what you've done. Take a look at what I've done here. Hopefully this video has been helpful to you as we get going on graphing, and kind of a double dose on a math lecture this week. All right, you guys did a great job. Way to hang in there. I know this was a long one. If you work through it with me, I am certain that you will be well on your way to getting this down pat. All right, I'll see you in class, guys. Bye-bye.